The other one is Lambda Delegation. Now I say delegation and not just broadly Lambda functions because Lambda functions can do so much and there's such a broad application of them, it would take me a really long time to go over those. But I think one of the coolest programming patterns involved with Lambda functions is called Lambda Delegation. And I learned this pattern of programming from Objective-C and Swift in my Apple days, and I've been able to convert it directly to C++11, and I'm actually finding it's a hell of a lot better way to work with invent callbacks or callbacks of any kind, as opposed to the ugly way it was done in C or pre-C++11 C++ code. Java programs work this way. JavaScript people use this a lot. I mean, C++ seems to be one of the only languages before this that doesn't do this. And I still don't even see it done that much since C++11 because people are just kind of slow to adapt. So Lambda functions, like I said, are local functions. They're objects, or they're not objects, they're variables that can hold functions, and functions become variables that can get passed around and called at will. In JavaScript, these are simply just called functions. In C++, or in Objective-C, they're called blocks. In Swift, they're called closures. I'm sure every other language has their own version of them, but C++11 calls them lambdas, which are computer science-y version of the name. And the way that this works is you basically use auto, which is another C++11 feature, which does type inference for you. And you'll give the name of the function, and you'll set it equal to a syntax that starts with a capture list, which is basically these empty square brackets to start with, an argument list, and then your function. Now, Objective-C corrupted me, and even though I like to put curly braces on new lines, this is one case where I don't. And then you put the code inside here. And that is basically you just declared yourself. This is the end of me typing standard double colon. I'm tired of it. All right. Yeah, you basically declared yourself a little function that you can call like any other function. So in my game loop constructor, I declare func and call it immediately, and then you'll see the result of me doing that in the log down here. Now let me explain a little bit more about auto because I just glossed over that. The basic gist of auto is, if you've ever seen Swift code before, it's just like let or var in Swift. Basically you can say auto, x, any variable you want, as long as you assign it to something, it will infer the type based off of the value that you're assigning it into. So for example, this case it's going to infer int. If I did this, it would infer double. If I did this, it would infer float. I think there's something for like unsigned int. I think there's something for, it doesn't matter too much. For example, a lot of people would frown upon you doing it with things like numbers because it's kind of stupid. You could just type int. But when you're setting it equal to things that have very complex return values, aka lambdas, it's very useful to just use auto in this case. So that's generally how I declare them. There's more about type inference in the auto keyword in C++. You can read up about it. I don't want to get too hung up on it. So that's the syntax for declaring a Lambda function. Now what's really cool about Lambda functions is that you can pass them as arguments to other functions. So for example, if I have this regular C function up here, you will see that I could actually pass func into this as an argument and call it. Now what does that look like? Well, once again, the syntax looks like shit for the actual type of a Lambda. You can blame the way C++ is for that. What I do in that case is usually I'll declare something called functional, or declare. I'll include something called functional, and then there's something called std function or standard function, which is a template argument, and then you basically say function, and then, God, I know I'm going to forget this. I believe it's just the arguments and the return value on the left, like that, and then the name. And then what I can do now is I can call func1. I should put a G in front of this so you know it's global. I don't want to confuse you too much. You can call global function 1, pass func in as an argument, and then you can call it inside here. And basically this is going to look nuts. All this just to still print the word hi there. But really what's going on, if I put a breakpoint inside the lambda and look at the backtrace, you'll basically see that I've basically, from main, skipped some C++ smart pointer stuff. I'm now in the game loop. I'm now in gfunc. gfunc called a function, and a function jumps down. Yeah, I just got confused. A function jumps into func, which was the argument. So that's really cool, but you can even do more. Suppose you have a variable here. A monkey. And you want to print that string. And maybe you have some other logic in here that actually modifies it, like you add some periods at the end or something. Now what you can do is you can actually print out the local variable from the outer function in the inner function, which is the lambda function. You'll get a warning here, an error telling you need to capture it, and the basic gist is you have to put it in the capture list. I'm just putting it here so it'll copy it. So it's capture by copy, and then when I call all these functions around, it'll still get the local variable and print that. So you can start to see the potential here is just awesome for programmers. Before Lambda functions, doing things like this was an utter, just terrible pain in the ass. Like it wasn't worth it half the time. And you would usually rely on function pointers to do callbacks and things that were very ugly. And I didn't even teach in my videos about function pointers because I think they're such a pain in the butt to work with, and often not necessary now. So that's what a lambda function looks like. You can see you can do a lot with it. You can assign them, you can call them, you can do whatever you want. And you can have them return values if you want to. So for example, if you wanted to have something here called double it and have it get an int as an argument, this syntax is to say that it returns int. It's on the right. I know it looks weird. But basically you can return x times 2 here, and then you could say double it, 10, and that should print 20. So there you go. So what the hell does any of this have to do with delegations and callbacks and the like? Well, we'll explain. So right now what I have is I have a button. When that button gets clicked, I've hard-coded in the mouse up method of the button what to do, which is basically just play this sound. This is not the right place for this, and a lot of times the implementation before Lambda functions would involve setting some callback state, or one of the things that SDL likes to do, which I'm not knocking, but it's the way it works, is you have this function that's always polling to see what the event was, and then you see what the event is, and you switch based off of it, and you do some other stuff. But you have to do this globally all the time. And also, you know, SDL is an implementer of this. They have to set all this global state all the time something changes, just so you can pick it up later. Well, what Lambda Delegation does is allows you to directly call into some other place in code that was interested in the event of the button being pressed. And I'll explain how that works. So we're going to pull in functional here. And what we're basically going to do is we're going to have a private variable here inside button, and it's going to be called, I usually give these the name handler, so I'm going to call this press handler, and it's going to be of type standard function. Can't believe I remember this syntax. Void, no arguments. If there were multiple buttons, maybe it would actually make sense for you to pass an argument saying which button was pressed. It'll be fun to explain to you guys what can go wrong when you do this, so I'll just put it in as an argument like that. And there it is. So this is press handler, and I want it to start as a null pointer, and that's important because it needs to be initially undefined. I think this is automatically done by default as well, but I just wanted to make sure. Then I'm going to have a setter here called setPressHandler, and it's going to take the exact same type. It's abbreviated PH here. And when I implement setPressHandler, you can guess how dramatic this is going to be. I just set pressHandler equal to PH. I could have inlined that, but I don't know, I just did it this way. So now what have I gotten myself with press handler? Well, I no longer have to hard code what happens in here. I'm going to cut this, and basically if press handler, call press handler right there inside button up, where the event occurs. And I'm going to call it with this because, of course, I'm this. I also noticed just now I forgot to derive standard enable shared from this button up here. That's going to be important. Oh god, what just happened? Cannot cast some shit. I think I've seen this before. Oh, if you don't declare this public, you'll get a very confusing error. It has to be a public subclass. Just a bad habit, I guess, not used to doing that. So, what have we earned ourselves by doing this, what I call Lambda delegation? Well, now it's amazingly simple to find out when that button's been pressed in code. I basically just say, right after the button's been created or wherever I want, set press handler, square bracket, capture nothing, no argument is button, the button that was pressed, and that's it. And inside here is the code that's ran when the button was pressed, which is awesome. So now I can just put it right here. And this was the code that played my sound. Now, of course, I need this pew sound effect, and I'm just going to go ahead and put this where it actually should have belonged in the first place, which is in the data of the game loop. Okay. Gotta love it when autocomplete stops working when I really want it to work. Usually means there's some kind of error. Okay, so basically this is one of those errors that kind of leads you right through. It says you have to implicitly capture this to use any of your own data. So you just put this inside the capture list and you got it. Of course, there's still some stupid errors somewhere. I wouldn't have mistyped it if you auto-completed it for me, asshole. All right. So now you'll see via Lambda delegation, I actually go right into the right place when the button was pressed. Isn't that nice? That's I think I made a mistake somewhere. Probably because I did not initialize this to null pointer, and I load it inside the callback, which is now no longer necessary. So it really would make more sense is to right up here set it equal to the load call, and then of course in the destructor, since it's a C object, I have to do the old school free on it. So I'm just going to do mix free chunk. Ooh. Let's hope that we get something a little nicer than what just happened. All right. So that's Lambda delegation. I use this everywhere in my game. I have this for callbacks of whether the gun hit a surface or whether the enemies collided with each other, or if the player was hit by a bullet. This makes programming like really nice, and that's one of the reasons why I wanted to talk to you guys about it and cover it, because it's so cool. So let me explain a little bit about button. So this B would be like a way for me to check to see which button was pressed, maybe, or I could do something like B get label to see what the label was of the button. So for example, I might do that real quick. Let me just quickly make inline string get label. Label. All right, so that's label, and then I can just say like cout label. Okay, so let me explain a pitfall that can happen, and this will be the last thing I talk about in this video. So there it goes. The label of the button was pressed, right? So that's cool. So one last thing I wanted to talk about here is retain cycles, because I think it's important, and I think it's kind of negligent of me to teach you guys about this kind of Lambda delegation without at least covering these in a small amount of detail. I cover them in depth on a post in my blog regarding retain cycles. So let me quickly go over what can go wrong here. So I've slightly modified the code here to create this create button function, which returns a shared pointer to the created button and call that from the game loop constructor. The way I had it before was the right way to do it. This is very stupid, having a global function to create a button, but it's how I demonstrate one case how this can go wrong. So basically, I took out the argument that has the label or the button as an argument during this press handler, and I'm going to try to use that mechanism of using an outer variable that I talked about before via capture, so the button can basically just, be used inside of setting its press handler. In other words, if I put button here as a capture, I can basically see out the button get label from inside the press handler, and there shouldn't be anything wrong, right? As a matter of fact, when I run it, it should work just fine. I don't play the sound anymore, but you can see the see out is happening. It's getting ran. Now let me explain how something as subtle as this just became a very serious problem. I'm going to highlight this by putting a breakpoint in the destructor of button. So there's the destructor for button. Put a little breakpoint. Now when the program quits, the button should be deallocated, right? What happened? Basically what happened was I created a retain cycle, and more seriously, I just leaked the button. And let me explain how that happened. Basically, there's a smart pointer to the button right here that gets created and is permanent, at least until the program quits, and gets passed into button here. That's the path of that. So here's the button, and here is one reference to that. Now here's the problem. When we call button set press handler, when you capture a variable, that variable lives as long as that function or lambda lives, which means this button reference or smart pointer is basically captured and held by the press handler, which of course is stored in button. That basically means button has a damn reference to itself. And because button has a reference to itself, and we have another reference to button, button will not release the reference to itself unless the press handler gets set to null, which won't happen until the destructor is ran, which basically means we have an endless cycle or a retain cycle, and the button will never get freed. Once this happens, it's too late. And the thing that's really scary about these kind of things is that they're very subtle. You won't even realize it happened until your game is leaking memory and you don't know why, and you have to go debug this. There's an easy way to make sure that you don't do this. And the best way is, and there's a reason why I love the fact that capture lists in C++11 are explicit, meaning don't do things like this where it captures everything in scope, because you might accidentally do something like this. So rule number one is make your captures always explicit, comma, list out the things you're capturing. The second thing is, if you ever type the name of a variable and you see that it is a smart pointer, think about, wait a second, is this being assigned into the same thing? Is this going into a scenario where I can create a reference cycle or a retain cycle? And if you're not sure, put the breakpoint in the destructor and make sure it's really getting called. And the third way is to use the weak pointer to get yourself out of this. If you have to do delegation this way, like I showed in the previous example, there's a lot of other ways to do delegation where you could pass the argument back in and stuff like that. But if you need to capture yourself in some weird way, the way to do that is to create a weak pointer instead. So you basically do auto weak button equals button weak pointer of the original. And then you capture only the weak pointer in here, and you do lock when you get it. And if you want to be really safe, you do if the lock to make sure it's not null before you use it. This breaks the retain cycle because one of the links is weak, and it won't keep the object alive longer than it should be. In other words, the breakpoint gets called. So that's retain cycles. I glossed over them kind of quickly, but I didn't want to leave them out because I think they're really important. We are now done, and I hope you guys have learned a little bit about C++11, or at least some of the more interesting features, in my opinion, that there exist in it. So that's the end of the video, and I'll just leave you with this.